Hello everyone and welcome back to NewtonNuts. In today's video, we are going to solve question 14 from the Edexcel International A-Level Physics Unit 1 October 2025 paper. This question tests your understanding on the principle of conservation of momentum and requires you to combine momentum and kinetic energy in calculations. So let's work through it step by step. This question combines two important topics. They are kinetic energy and the principle of conservation of momentum. So we shall move to the question. Two rocks in outer space are moving at different speeds along the same path. Part A of the question state the principle of conservation of momentum. Conservation of momentum. To apply the principle of conservation of momentum, external resultant force acting on the system should be zero. That means there should be no external resultant force. And when there is no external resultant force acting on the system, initial total momentum of the system is equal to the final total momentum of the system. That means momentum is conserved. So we shall write down a proper answer for this question. So you are given 2 marks for this question. So there should be 2 points in the answer. So we shall write down the answer like this. If there is no external resultant force acting on the system, initial total momentum is equal to final total momentum. So if you write the answer like this, you will get full marks. So that now we shall move to the part B of the same question. Rock A has a mass of 43 kg and a velocity of 7.8 meter per second. Rock B has a mass of 56 kg and moves in the same direction as the rock A. The kinetic energy of the rock B is 4.1 into 10 to the power 3 joules. Like in the previous questions, we shall sketch a diagram for this scenario. So there are two rocks A and B. So the rock A has a mass of 43 kilogram and that moves with the velocity of 7.8 meters per second. And rock B has a mass of 56 kilogram and it has a kinetic energy of 4.1 into 10 to the power 3 joules. And in the question, they are saying that both these rocks are moving into the same direction. We shall go forward in the question. Rock B collides with rock A. After the collision, rock B continues to move in the same direction with a momentum of 530 kilogram meters per second. So then they are saying that the rock A and B collides each other, and after the collision, the rock B moves into the same direction with a momentum of 530 kilogram meter per second. So you are asking the new velocity of the rock A, and we don't know the direction of motion of the rock A also. We shall try to solve this problem. we have to apply the law of conservation of momentum here because there are no external resultant forces here. So basically, the law of conservation of momentum says that initial total momentum is equal to the final total momentum. Yeah, we shall check whether there are enough data in this question to find the initial total momentum. Yeah, so the initial total momentum should be the momentum of A plus momentum of B, no? And you know that momentum is the product of mass and velocity. When you consider the object A, it has a mass of 43 kilogram and a velocity of 7.8 meters per second. So since they have given the mass and velocity, we can find the momentum of A. But in B, they have given only the mass, not the velocity. But they have given the kinetic energy here. So with the kinetic energy, we can find the velocity of the object B, and then we can apply P equals mv and we can calculate the momentum of B. Then to find the total momentum, we can add those two momenta together. So we shall do that one first. First, we'll calculate the velocity of B. Actually, this is the initial velocity of B. So you know that kinetic energy is equal to half mv squared. So kinetic energy is 4.1 into 10 to the power 3 joules, half into the mass is 56 kilogram into V squared. So we have to find the value of V here. So V is equal to 2 times 4.1 into 10 to the power 3 divided by 56 square root. Yeah, so the answer comes as 12.1 meter per second. This is the initial velocity of the object B. So next, I'll find the total initial momentum. So total initial momentum is the sum of initial momentum of A and initial momentum of B. So the initial momentum of A, that is the mass is 43 kilogram and the velocity is 7.8 plus momentum of B, mass is 56 kilogram and we calculated the velocity there, that is 12.1 meters per second. So when you solve this one, the initial momentum comes as 1013 kilogram meter per second. Yeah. So then, so you know that according to the law of conservation of momentum, initial total momentum should be equal to the final total momentum. So we shall equalize the initial total momentum and final total momentum. So initial total momentum is 1013 kilogram meters per second. Yeah, we shall understand about the final total momentum. So the final momentum or the final total momentum is associated with these quantities. So in the question they have given that the final total momentum of B is 530 kilogram meters per second, and after the collision the object B moves into the initial direction. So it should be a positive momentum there. So basically final total momentum is also the final momentum of A plus final momentum of B. So we shall go with that one. Final total momentum is equal to final momentum of A plus final momentum of B. So first we shall find out the final momentum of A with this question. Initial total momentum is 1013. Final momentum of A plus the final momentum of B is given as 530 kilogram meter per second. So final momentum of A is equal to 1013 minus 530. So the answer is 483 kilogram meter per second. So that's also a positive value. That means finally A also moves into the same initial direction. So finally we have to find the final velocity of the object A. So we shall apply the equation P equals mv there. P is the momentum, m is the mass, and v is the velocity. So the final momentum is 483 kilogram meter per second. Mass is 43 kilogram, and we have to find the velocity. So final velocity is equal to 483 over 43. So the final answer is 11.2 meters per second.
If this video made that light bulb go off in your head, do me a quick favor. Smash that like button and subscribe to the NewtonNuts channel. It really helps me keep creating these free lessons for you. Now, if you want to completely ace your upcoming exams and need a little extra support, I've got something special for you. Head over to www.newtonnuts.com right now. To make sure we are a perfect fit for your learning style, every single student gets a 30-minute, one-to-one free trial class before we officially begin. No strings attached, just 30 minutes of dedicated, personal physics help to kickstart your progress. Thanks for tuning in today. If you enjoyed this lesson, stay tuned. I'll see you in the next video with more exciting topics.